Alright, so this video is meant for my Algebra 2 students. We have a test on Friday covering Chapter 4. This is your sections 4.4 through 4.6 test review. Second half of the chapter only. So we'll take a look at a couple of problems for each of these sections. First problem here. Solve the absolute value equation. Check your solutions. We're not going to check our solutions. We're just going to solve. Okay? We need to remember those bars. Absolute value means 2. Remember that for all these absolute value problems. So we're going to take this equation, and eventually we have to have two solutions. But there is an issue with this equation, and that issue is this plus, this minus 9. That is an issue. You have to take care of that first before you can get your two equations. So I'm going to rewrite the equation down here. Absolute value of 5 plus 4x minus 9 equals 8. I'm going to add the 9 first to get rid of it, so that the absolute value of 5 plus 4x is alone. Now I can separate this into two equations. Two equations. The first one is 5 plus 4x equals 17, the positive. The second one, 5 plus 4x equals negative 17. There's the second equation. And now we just solve each one. I'm going to slide it down a little bit. Subtract 5 from both sides here. 4x equals 12, and divide by 4. There is one of my solutions, x equals 3. But there are two solutions to this problem. Subtract 5 to the other one. 4x equals negative 22. Divide by 4. This, both can be divided by 2. So I'll get negative 11 over 2, or you can do the decimal, which is negative 5.5. Absolute value, 2 answers. Okay, here's the second problem. We're going to write an absolute value that has these given solutions. So now this is kind of going backwards. So it's telling me that x is negative 4 and x is 6. What is the absolute value equation that represents this? Well, remember, we are looking for something like this. The absolute value of x minus the average equals the distance. So again, if I have a number line, negative 4 here, 6 here, the middle is the average, and the distance that I'm talking about is that distance from each number to the average. Okay, so two things I have to find. First is the average. To find the average between two numbers, we add them together and divide by 2. Negative 4 plus 6 is 2, and 2 divided by 2 is 1. There is my average. Now, to find the distance that my numbers are away, I take one of the numbers, probably the top number, 6, and I subtract the average, and I get 5. So, what is the absolute value equation between these two numbers? It is going to be the absolute value of x minus the average, which is 1, equals the distance, which is 5. Alright, next question here is a word problem. Okay, it says specifications for a product require that its length be within 3 millimeters of 125 millimeters. Write an absolute value equation that has the upper and lower allowable lengths as its solutions. Okay, well, we're going to write an equation just like the one above. X minus the average equals the distance. However, these two numbers are not the solutions. The solutions are what you need to find. Okay? They're going to be the upper and lower allowable lengths. These two numbers are the average and the distance. The product can be within 3 millimeters. This is the distance. 3. Of this 125 millimeters, which is what you want to shoot for. That's the average. So on the test, you'll be given this equation, but I just want to do this problem to find the upper and lower allowable lengths. So here, the equation that you'll be given, like I said, is x minus the average, which is 125, equals that distance of 3. So now we want to solve this, okay? We want to solve this to find the upper and lower allowable lengths. So remember, absolute value means 2. Two equations. X minus 125 equals 3. And x minus 125 equals negative 3. Two equations, two answers, an upper and a lower. So let's solve. Add 125 here. X equals 128. Add 125 here. X equals, now the 3 is negative, so you take 3 away, 122. So what are the upper and lower allowable lengths? So the upper is going to be this 128, and it's in millimeters. And the lower is this 122, and it's going to be in millimeters. And there's this word problem. So again, the equation will be given to you. I just wanted to walk through the solution and how to interpret it. There we go. Okay, now we move on to inequalities. So now we're going to solve the inequality and graph the solution. Okay? So here we go. First thing I see absolute value bars, which means 2. I'm going to have two inequalities involved. Now, I see a less than. Less than, those last two letters should point you to and. And means you're going to have a compound inequality with two inequalities in one line. Okay, so the 4x minus 3 is in the center. There's a 5 over here, and we take the opposite of 5 or put negative 5 over here. And now, 4x minus 3 must be less than 5, and 4x minus 3 must be greater than negative 5, or negative 5 must be less than 4x minus 3. Remember with this and, you just take the inequality and you write it twice. That gets you the inequality, the compound inequality, and now you solve. There are 3 parts, so you do everything 3 times. 3 parts, 3 times. X in the middle is what I want. Add 3. Once, twice, 3 times. This is negative 2, less than 4x, less than 8. Divide by 4, divide by 4, divide by 4. I can divide each of these by 2 to get negative a half, less than x, less than 2. Or you could have negative 0.5, less than x, less than 2. Either one would work. And now we graph it on a number line. Here's my number line. Negative a half is on the left, 2 is on the right. They are not equal to, so we have open circles. And where is my x? It's in between. So where do I shade? In between. Okay, similar problem here. Same instructions, solve this. Now we have the absolute value of 3x minus 6 is greater than or equal to 15. Again, absolute value means 2. You set up 2 things. Now, this is a greater symbol. Greater means or. That is 2 separate inequalities. 3x minus 6 greater than or equal to 15. Exactly what it says. The other one, though, or 3x minus 6. Now, this is greater than, so that's pointing to the right, greater than. So we have to be less than, because we have to point the other way. Remember these graphs, these OR graphs, for an OR graph, it always points outward. So this one is greater than, this one has to be less than, and we flip the number around. Negative 15. And that's going to ensure that we get our arrows pointing outwards. So let's see. I'm going to add 6 here. 3x is greater than or equal to 21. Divide by 3. X is greater than or equal to 7. There's the first one. Over here we're going to add 6. You'll get a little different number though. 3x is less than or equal to, this is negative 9. And divide by 3. X is less than or equal to negative 3. There's my OR in between them, and there is my inequality here. It's an OR. So now when I graph it, my arrow should go outwards. O for outwards. O, outer. Negative 3 here. 7 here. Equal to, solid. Solid. At the 7, my arrow is pointing to the right. At the negative 3, my arrow is pointing to the left. And there's your graph of your compound inequality, or for an absolute value with a greater than symbol. Okay, so here's the next problem. It's going to be an absolute value inequality. It's a word problem, though. So it says that absolute value inequality describes a wrestler's weight on the day of a weigh-in. So I want you to solve and interpret the solution. Interpret the solution. Okay? So here it is, w minus 62, absolute value of w minus 62, less than or equal to 2. This is an absolute value. So there are two inequalities I need to set up. This is a less than. That means and. Less than and. So the w minus 62 is in the center. 2 over here, negative 2 over here. W minus 62 must be less than or equal to 2, and W minus 62 must be greater than or equal to negative 2. Notice though, negative 2 then has to be less than or equal to W minus 62. And again, with the and, it's just the symbol copied twice. 3 parts, 3 things we do to get W alone. Add 62 to both sides. 60 less than or equal to W, less than or equal to 64. Here is the solution. So the question is, how do we interpret this? Well, this is representing the wrestler's weight. So the wrestler's weight can be between, now this is in pounds, I'm sorry that's the problem to say, it's in pounds, can be between 60 pounds and 64 pounds inclusive. Inclusive means that's the equal to part, inclusive. And there we go. All right. So this is some sort of a weight class. Maybe it's a middle school wrestling. I don't know. 60 to 64 pounds is where this wrestler can be. Pretty small weight class. But there you go. That's how you interpret the absolute value inequalities solutions. Okay, next problem here. We're going to evaluate an absolute value function. So I have two x values. We'll do one in red, -1, and one in blue, which is 3. Into this function, c of x equals absolute value of x plus 3 plus 4. So first of all, I want to show you that I could also have written this as c of -1. Find c of -1. What means is x is equal to -1, and I plug it into c. So that's what you could have wrote as well. But here's my function. Plug it in. C of -1. X is -1 equals the absolute value of -1 plus 3. Close the absolute value plus 4. I need to get a single number in here first. So it's going to be the absolute value of, and -1 plus 3 is positive 2. Now I have to take the absolute value of this. The absolute value of 2 is 2. I'm going to add 4 to it on the end because it says add 4. And there's 6. So c of -1 is 6. Now again, this could have said c of 3. Find c of 3. So c of 3 is going to be the absolute value of 3 plus 3 plus 4. 3 plus 3 is not the absolute value. Get a single number in here first. 3 plus 3 is 6. Absolute value of 6 is 6. And 6 plus 4 is 10. And c of 3 is 10 in this problem. Plug in x, get a single number, take the absolute value, and then simplify. Okay, last two problems coming, a couple graphing ones, okay? So first we're going to tell whether the function opens up or down. Is it wider or narrower than the graph of y equals absolute value of x? And then you're going to graph it as well. Okay, so what we're going to do is we're going to take a look at this function and identify the a value. Remember that a value is very important. Underneath it I will write y equals a absolute value of x. This a value, this multiplier, this coefficient tells me a lot. So in this problem, a is -7. So first, it's negative. What does that mean? That means it opens down. So it's going to be flipped upside down. Second, we compare the number, not the negative symbol, but just the number 7. We compare it to 1. And we ask yourself, is 7 greater than 1 or less than 1? 7 is greater than 1, which means your slope of your sides is going to be steeper than 1, which means that your graph is going to be narrower than the absolute value of x. All right. So Let me draw my graph over here. I'm going to use red as the axes. I'm going to put 7 because I assume I have to do 7 somewhere. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, so let's see. So remember, we treat that A as the slope. -7, put it over 1. A is -7, put it over 1, which means down 7 and to the right 1. So first off, 0, 0 is every vertex of all these absolute values. And then we're going to go down 7, 1, 2, 3, 4, 5, 6, 7, and to the right 1. And that gives me the right side of my graph. And I like to label these points from here, go to the right 1, and down 7. That's the point right there. 1, -7. Now, there is symmetry. So if I take this point and just go straight across, I'll get the same exact point. Okay, well this is 1, -7, so that's going to be -1, -7, right there. And there's the right side. And again, remember, if the point xy is on your graph, then the point -xy is on your graph. And there's the graph of this absolute value inequality, opening down, and it is much narrower. If I, in light blue, if I just do 1, 1, 2, 2, of course negative, there's the regular graph, flipped upside down. This would be the graph of y equals the negative absolute value of x, flipped upside down. So notice it got narrower. Okay, let's try one more graphing. Okay, last problem here. This is number 9. Same instructions as the previous problem. So we take a look at this graph. I'm going to say y equals a absolute value of x. Identify that a value as 2/3. So we say, okay, first, that's a positive number. And if it is positive, that means we open up. So I'm going to be opening up. And 2, we look at the number 2/3. Again, if it was negative, we just look at the positive. And we ask ourselves, how does 2/3 compare to 1? Well, 2/3 is 0.67. Less than 1. 2/3 is less than 1, which means your graph gets wider. It gets wider. Okay? So I'm here. 5 in each direction is good enough, I think, for this. Treat your A as the slope. 2/3. Down, sorry, not down to. It's positive, right? Up to the right 3. So 0, 0 is always on my graph. I go up 2 and to the right 3. There's this side. I want to label this point. That is the point 1, 2, 3, 1, 2. Use symmetry. If 3, 2 is on the graph, then negative 3, 2 is also on the graph. 1, 2, 3, 1, 2. Negative 3, 2. And there's the graph. And again, just to show you, now since it's positive, we'll take a look at y equals absolute value of x. That'd be 1, 1, 2, 2, negative 1, 1, negative 2, 2. There's that graph. So notice your graph got a little wider. All right. Hopefully you think this helped. We have a great test day on Friday and have a great end of the quarter. All right. Good luck studying.